You see, it is a sharp frequency response having a peak only at one particular frequency. So the gain bandwidth product is also going to be small. So even though the gain is large, the bandwidth is small. So GBW product is very, very small. In double tune, the frequency response is flat and it is going to have steeper end, and the GBW product is also going to be large. When you compare to stagger tune, the response is going to be almost same like your single tune only. So the gain bandwidth product is very, very small in this case also. So it is going to be small in the stagger tune circuit also. And single tune amplifiers are very easy to design. You know, you have only one LC circuit, so it is very simple. But double tune amplifiers are very, very complex to design because I have two tune circuit. So either manually connecting two inductors and two capacitors is difficult, or using a transformer is also going to be difficult. And more than that, having a same F naught across all the tune circuit is going to be very, very difficult. You cannot maintain the same center frequency and bandwidth across all the tune circuits of a single tune amplifier. Okay, and for stagger tune, the design is same as single tune. So whatever difficulties you face in single tune, the same is applicable for stagger tune. And in single tune, no isolation is required between stages because I use only one LC tank circuit. Here, isolation is provided by the transformer, which is going to separate the second stage from first stage. Since I have two tuned circuits in my circuit and double tuned amplifier, there is a need for isolation to separate the two tuned circuit stages. That is done by the transformer. Transformer will ensure that the two tank circuit present collector side the collector side will be completely isolated. And in stagger tune, no isolation is required because it is made up of single tuned only, right? So no isolation is required for stagger tuned amplifiers. In the circuit diagram, you see it is for single tune, it is a conventional common emitter amplifier. In the collector side, I am going to have one LC circuit. Okay, this is the difference. This is where you have to know the difference. Double tune, conventional common emitter amplifier. In the collector side, I am going to have a transformer. Primary, I am going to have one capacitor. Secondary, I am going to have one capacitor. And both the tuned circuits will have the same values for inductor and capacitor. You see L1, C1. Here also L1, C1. Stagger tune, it is going to be two single tuned stages. But see the value L1, C1, L2, C2. So when you change the values, the resonant frequency of the stages are going to change, which will lead to what is called as stagger tuning. So this is all about the comparison of tuned amplifiers. So we have compared the tuned amplifiers with respect to first one is your how many tuned circuits are present. Second one is how the resonant frequencies are designed in your circuit. Third one in terms of bandwidth. Fourth one in terms of the frequency response characteristics. Fifth one in terms of circuit complexity. Sixth one in terms of isolation between the stages. And seventh one, we have drawn the circuit diagram. So once this table, if you are very clear, then it will be helpful for you to understand the individual theory and derivation of single tune, double tune, and stagger tuned amplifier. I hope this comparison is clear to everyone. Any doubts, if you have, you can ask. Okay.